Hello everyone, this is Dmitry from Galileosky. In this video, I'd like to tell you about two tracking device operation modes, in motion and during stop. In most cases, users are not very interested in the telematics data while the vehicle is parked. That's why trackers work a bit differently while moving and after the stop. Tracking devices correctly update coordinates and speed in motion. They record points according to settings of the in motion mode. Also, the device records additional points when drawing turns, and because of some additional system events. For the during stop mode, the period of recording points is set separately, but this is not the only difference. The main one is that the device freezes coordinates when parking. It is done to avoid false mileage overlap and stars appearing in the track around the parking spot due to inevitable satellite data fluctuations. It is extremely important to make correct settings to clearly determine the operation mode. Otherwise, the software may receive the same coordinates despite the vehicle is actually moving. So, how can the tracker determine the moving or stop mode? Let's take a look at the options in the descending priority order. The first way to determine its state is using the ignition input. This mode has the highest priority, and if the ignition input is set, the device works according to the logical state of the selected input. Start the configurator, go to the settings and open the track tab. Here you can assign all of the tracker's inputs as the ignition input. Now the device will work according to the in motion mode settings when the selected input logical state is 1 and according to the stop mode when the input logical state is 0. Please note that you also need to configure the input itself. Let's go to the Inputs Outputs tab. We have selected input 3 as the ignition input. Set the operation mode of this input as the min value. We also need to set logical 0 and logical 1 levels on this input. Let's assume that the device is installed in the car, and when the ignition is on, the voltage at the input is higher than 12 volts. Now we set the level of logical 0, which is the red zone, from 0 to 5 volts to cut off the possible noise at the input. Then we set the logical 1 from 8 to 33 volts. In general, those settings are quite suitable for any vehicle. Please do not forget to apply settings. The ignition input setup is now complete. Be careful when setting the ignition input. If you specify the wrong input or the ignition signal is not actually connected to this input, the device will always run in the stop mode. The second way of determining the parking and driving modes is based on measuring the voltage of the device's external power supply. The point is that when the engine is running, the vehicle generator is also running and the onboard voltage is higher. When the engine is off, the tracker receives power from the vehicle battery and the voltage is lower. So, let's try to configure the device according to power supply voltage. Start the configurator and go to the Device tab. In the Service Information field, we can see the external power supply voltage. Start the engine and memorize the supply voltage when the engine is running. Now, turn off the engine and memorize voltage when the engine is turned off. Go to the Settings and open the Track tab. Remove the ignition input settings. Here, we can also set the voltage thresholds when the engine is running and when the engine is stopped. The logic of these parameters is exactly the same as when setting the logical levels on the device inputs. That is, when the voltage is between 0 and voltage threshold for the turned off engine, the device considers the engine is turned off. And when the voltage is above the threshold for the engine is running, the device works in the in motion mode. In our case, the voltage was 12.4 volts when the engine was off, and when the engine was running, it was 14.2 volts. So, we set the voltage of the stopped engine to 12.7 volts and the voltage of the started engine from 13.2 volts. Do not forget to apply settings. This completes configuring the tracking device according to the power supply voltage. The third way is working according to built-in accelerometer readings. Each Galileosky device is equipped with the accelerometer, which, among other things, can be used to detect whether the vehicle is moving or standing still. This mode is used by default, and the only parameter that needs to be set is the accelerometer threshold. Please note that if you want to use this mode, it's extremely important to properly fix the device. Vibrations from engine operation and vehicle accelerations should go to the device housing. You can use zip ties or double-sided tape to fix it, but the tracker must be fixed to the rigid parts of the vehicle body. We do not recommend installing the device on the wire harnesses or any other elastic surfaces that can absorb vibrations. So, our tracking device is securely attached to the metal part of the vehicle body. Run the configurator, open the settings and go to the Track tab. Remove the settings of the power supply voltage. Just set 0 in both lines. As I said before, the only parameter of the accelerometer is the threshold. When the accelerometer shows the measured acceleration value above this threshold, the device determines the in-motion mode. The default threshold value for the accelerometer is 40. This value is fine for the most passenger cars. However, if you see that the in-motion mode is not always activated when the vehicle is moving, you can lower the threshold for the accelerometer to, for example, 20. Like I said before, these three modes have different priorities. If you made settings for all three modes, the tracker will work according to the ignition input logical state. If the ignition input is not set, the device will use the power supply voltage. And only if no settings are made at all, the tracker will work according to the accelerometer data. So, we have figured out how to configure the device to identify if the vehicle is in motion or parked. This was Dmitry from Galileosky. See you later.